Hello, my name is Dietmar Fuchs. I'm the product manager from ColorLogic. I will show you shortly the three ColorLogic products we are using here. We start with ColorEnd for measurement data optimization. After having our measurement data, we are going over to CoProf for the ICC profile creation. And after that, we are using Zebra, our color server, to convert the PDF documents to our sub-7 color space. So let's have a look first on ColorEnd. What we need for to get going, to calibrate and to characterize our printing process, our sub-7 color printing process, we first need a test chart. So for doing that, we need the custom chart option here. And here you select the color space you're in. So we want to go for 7 colors here. You define the mode you want to do. So we want to do profiling. There are other options here as well. You would define the colors we want to use. That would be in orange, green, and violet in our case here. You select that. And depending on the size of the media you want to print on, for example, if you're printing on a small can, you need smaller sizes and less patches, probably because you don't have so much space. If you have more space, you would use a large colors patch list, 3,300 patches here. And depending on the space, you would either use large, medium, or small. So let's take the large one. So this will create the patch lists, basically, that we are going to print on in our printer. We could use any kind of measurement data here or reference data here. For example, as well, the Ideal Lines 7 color test chart, which is an international organization that have standardized on the 7 color space, similar to what you all probably know from the CMYK with the IT8 charts. There's now a 7 color chart. We could use that as well. And from this patch list, we would generate a test chart suitable for our instrument and our printing process. For example, depending on the measurement instrument, we have support for a lot of different measurement instruments. For example, for an I1 IO, we can define the layout for the instrument, and it would tell us that we would need 4 pages of this test chart to cover all our patches. If we click Start here, then we have the choice of the format we want to have that test chart in. Typically, I would use a PDF document, but we can have a TIFF or Photoshop PSD file as well. And once I click here, so I can give it a name here, and I would click Save. And my test chart would then be ready to be used. And what we'll see here as the next step is that we have our reference data, which is basically in the layout of our PDF document. So our PDF document has our 4 pages, and the pages are organized in such a way that we could measure them in the order that we have listed it here. So for measuring, we would use the measure tool. Here again, we could measure with all the instruments that we support. In our case here, it's for the I1 IO, so we measure it with the I1 IO. I don't want to measure it here because that would take too much time. So I will load existing measurement data from a 7 color indigo, CMYK, orange, green, and violet. And then the beauty of ColorEnd here is that whenever you're working with measurement data, I can double click here and have different views on my measurement data. So that's my 3,100 something patches. I can see it in 3-dimensional view. I can see how the orange, green, and violet expands on my CMYK color space. So I can see that this really gives us more latitude to simulate spot colors on that press. So that's quite nice. As long as you are working with a lot of patches, there is the good probability, or there is a probability that there is something wrong in the measurement data. And if you don't fix that, your profile won't be good. So it's very important to be able to fix a lot of issues that can happen in measurement data. And therefore, all those tools that you see here can be used. We will do a little bit of what we can see here. For example, if we look into the curves, we see here, for example, for the black, that there are, for 60% black, multiple measurement data. We call this redundancies, and they're not the same. And that is an issue. The same is here, and that's the same here. So we have a lot of those not perfect aligned measurement data here. Maybe we can see them and spot them in our three-dimensional view already. So let's have a look. If we see it here, we can see that our 60% patch has two different values. So which one is the right one? So we obviously, that might be an error in the measurement data here. And therefore we need some tools to fix that. Tools that we have here is to fix the redundancies, correction, and smoothing. That will be applied by using the automatic tool. I will do that, and we can see what happens to our data, because all what is applied here will be shown as well in our visualization here. And finally, the smoothing will be applied, and we'll see what's happening after that. So we can go through our steps. So the original data was that. Now we do some averaging. This will fix the two measurement data which have been different LIB values, but you'll see that's still not fine. Now we need the correction tool to fix this little thing. And finally, the smoothing will make a little bit nicer spacing of the patches that we are seeing here. And this is just an example for the black. We'll do that obviously for the entire color space. And that's very important. So this tool ColorAnd is really helpful for all kinds of profiling tools, not only the color management tools from ColorLogic. This can be used in front of all kinds of profiling tools to really fix the measurement data and to optimize the measurement data. That's very important. So that's the first step. We need to test chart, except for 7 color. We need to print it, measure it, and optimize the measurement data. And after that, you simply save this data into multiple formats like CGAPS formats, CXF formats, you name it. There are a lot of different formats that are used within our industry. So we'll save it as a text file, as a CGAPS file, and now we have our perfect measurement data that we want to use in Copra for our profiling. Copra is a powerful profiling application that can create printer profiles. So there are two options for printer profiling here, for DeviceLink profiling, and we will start with the printer profiling here. For that, I click on printer profiling, disable the measurement data for a different data set that I had. I will load my optimized measurement data, simply drag and drop the measurement data in here. Then I need a setting, and the settings can then be customized. So for how the perceptual rendering should be working, there are multiple options here. The color generation options, the typical thing that every profiling application has, like GCR control, black start, and so on. And depending on what we are seeing here, we know what we are doing here. The black point can be defined, the total area coverage, for example, or how much black we use. And what's quite helpful and unique in our applications, we can see the impact of our settings on our Gamut. So for example, we all know if we reduce the black, we will reduce our Gamut. And we will show that in the volume here. And we can see it as well in our Gamut view. If I add the black here, we'll see that we have a bigger Gamut by using that. And this kind of visualization helps you to determine which kind of settings you really want at the end. And you can see as well which kind of impact your black point settings, your black tag settings has on your black point. For example, if I reduce it to 300 or use 350, then I have a lower L star value, giving us more density, more contrast, and a nicer profile at the end. So we want to use as much tag as possible, but as less as needed for printing as well. So with that setting, we are fine, and we can create our ICC profile. We would give it a name and can save it either as an ICC version 4 profile or version 2 profile. We can even create a nice report that gives us some indication how good our profile is. So I've created that profile already, so I don't need to have to do that now. But the tool has a lot of functionalities here. The next step would be, now that we have a printer profile, we need a DeviceLink profile. And there are two ways of doing that. First, we could use it here in Copra to create our printer DeviceLink profile. we select our source profile and our target profile. Here it would be our 7-color profile. Let's see if I find something here. Here we go, 7-color profile. And then I can, again, via customize, define a lot of different settings for the profiling. We have indeed a lot of settings here, which might be intimidating if you don't know a lot about exceptions and color saturations settings and so on. But therefore, it's always a good choice to work with the presets that we have. For example, this one. This will set already a lot of those settings already for you, and then you are able to do some customization and tweaking to your liking, and can do a lot of things here. So that's one way of creating a DeviceLink profile, and with a DeviceLink profile, the quality of your conversion, in our case from ISO-coded version 2 to the 7-color, will be much higher than just using a normal multicolor printer profile. So that's one thing why we use DeviceLink profiles for. And the other way of creating the DeviceLink profile is automatically within our color server Zebra already. And I will use that functionality here for our purpose. So now we have created our measurement data with ColorEnd, used Copra for the 7-color profile, and that's basically all we need to set up now in Zebra our conversions. Zebra is our color server. It processes PDF documents, TIFF files, PSD files, JPEG files, so pixel files and PDF documents, complex PDF documents with all kinds of vector elements, text, images, all kinds of color spaces. So that's all possible within Zebra. And to set it up, you would go here to the Home button, and you would use the Auto Setup functionality here. Within that Auto Setup wizard, there are a few workflows, the typical workflows basically that you want to do, and depending on your license, one of the license here, or the license I'm using here, is the multicolor license as well, the biggest license, where we have as well the support for multicolor, spot color conversion, save ink, and all the things you basically need to do everything. And what we want to do is we want to convert our document consisting of CMYK in source color space to our 7-color color space. So we want to normalize and convert our colors to a new output condition. So that's our first and most used setup mode. Therefore, it's on top. So you select that. The next step, you decide either to use your already existing DeviceLink profile that you would have prepared upfront with Copra. You could select that DeviceLink profile here. Or you use SmartLink, which is our naming for the dynamically created device links on the fly. And we would use that option here, in which you would define what is your source color space. So what is your output intent, so to speak, in your PDF documents. You could make it very dynamic, meaning that if you check that option here, prefer output intent, all files which come with a certain output intent will be honored, and from that output intent to the target color space, a new device link will be built. And if there's no output intent, then your default ISO-coded profile here in this case would be used. As your target color space, you would select your 7-color color space. I have to pre-select that. You can select it from the list of the profiles that you have inside. You can even search for profiles, so that's all fine. You would select rendering intent, the typical 4 ICC rendering intents, plus the additional ColorLogic render intents can be used. Obviously, we want to use our rendering intents here. We claim to have quite good quality, and therefore we want to use our options here, standard compression in this example. There are what we call SmartLink methods. That's basically DeviceLink presets that we want to use. We deliver those DeviceLink presets here, and these are my custom settings that I can create myself with the help of Copra. Setting that I can define in Copra can be shared with Zebra. This way I have my own specific settings that I want to use. In my example here, I'm using a digital printer, which is a toner-based system here in my example. So I can start very well with this preset that we are delivering here. So we are using this one. I click on continue. Then we typically define a queue name automatically based on the settings we are selecting here. I will make that a little bit shorter, ISO-coded version 2 to 7 color indigo. So that's fine. So I'm creating my queues now and my configuration, and I'm not yet done, but fine, nearly I'm done. My configuration, my queue has been set up. And to go to the details here, because we want to convert some spot colors, we need to do something first. We need to go to the settings here, to the global settings for the spot color libraries, because we need to set up our spot colors for our conversion so that Zebra knows what to do with those 2 spot colors in our example, the 2 Pantone colors. For that, I have already prepared a spot color library that I want to use. That's this one. And here is my Pantone Reflex Blue and my Pantone Red 32C. In this example here, this is just a full tone. I have a 100% value only. At least we have spectral data, which is shown here with the name remission. If it's only LIB value, we would show that it's only LIB here. Spectral data is always preferred because with spectral data, the overprint calculation of colors can be made much more accurate than with LIB data. So we have at least the full tone in spectral data. Much better would it be if we would have as well a gradient information. And here with Zebra, we have here for the Pantone Reflex Blue, we have a full gradient. The gradient's helpful, for example, if in a design there's a 50% or whatever kind of percentage of such a spot color, here we would have the target values that we want to achieve. So therefore, gradient information is quite helpful. Else, if we don't have gradients, as in our example here with the red Pantone color, we'd have to assume a certain gradation behavior, let's say, and that we would apply that and would use that method here. So in our example here, we have target values that we want to reach. And even nicer would be if we would have as well some opacity values. For example, here, let's see, here we have a color. We don't need that color here, but it's as well printed not only on white, but as well on black background. And with that black background information, we can calculate the opacity of that color, because obviously if a color is very opaque and it prints on top of a different color, the other color won't show through. If it's very transparent, the other color will show through a little bit, and therefore this mixture, the overprints, will be different. And if we have that information and the color server has that kind of information, it can even better calculate the overprints. So in our example, we have those 2 colors here that we need, and we need that spot color library here, the spot gradients X4 in our conversion, in order to take advantage of those measurement data that we have inside here. Typically, for the spot colors, when you're starting as a new user, let's say, there wouldn't be any spot color libraries in here, but you have a lot of possibilities to load your own libraries, and you could even measure and create your own libraries within Zebra. So you can load CXF X4 data, all kind of CXF data, by the way, text data from various sources. You could load a named color ICC profile, you name it. There are a lot of different formats that we support here to import different kind of spot color libraries. And if you have a Pantone Live license, for example, we have support for that directly here as well. So we could use Pantone Live as well. So once you have your spot colors, that's basically the big work to get your spot colors in the system. Once that's done, it's then quite easy. You can always go back to the overview dialog here, double click, then you are within the configuration, and there are different tabs. We don't go through all those tabs, just the main tabs here, the document to target. We are converting from ISO-coded to our 7 color space using SmartLink with our SmartLink method here. Under image vectors, we have all the color space definitions for CMYK, RGB, gray, LIB for image and vectors. Typically, we want to convert images and vectors the same. Therefore, you don't have to set something up here. Typically, all those settings are from the auto setup, set up in a way that is logical. So you can change that if you want, but you don't have to. So it's basically all set up. Typically, for spot colors, we don't convert spot colors, so we maintain spot colors typically. If you want to change that, you would go to the tab for spot colors, convert spot colors, And here our spot color library comes into the equation. Here we would use our spot color library. For my long list of spot color libraries, I need to select my library here and move that to top. And I have a lot of options here. For example, a very modern way of communicating spot colors is to embed the spot colors as CXF-X4 data into the PDF. And Zebra is able to read this information if it's available on the PDF documents. So that would be a very nice way of working in the future if more and more applications support CXF-X4 data. By the way, with ColorEnd, you can do that already. So if you have CXF-X4 data, you can create them with ColorEnd. You can embed that in your PDF documents. In this way, you can already combine PDF documents with spot colors correctly so that they are self-contained and don't need a library. So we can use that. And the way that works here is Zebra would first look into that library. If it doesn't find a spot color here, it would look into the next option that we selected here, if embedded CXF data, and you could select other libraries here. And if still there is no spot color available, then Zebra would use what is defined here, undefined spot colors. And in our example here, there is one undefined spot color. So remember, if I go back here, my die cut line, that's not yet defined. It wasn't in my spot color library. What shall we do with that library, with that die cut? So at the end, we want to print it basically on our 7 color. We have options here to say either we want to keep that spot color and don't convert it. We can as well let Zebra give us an error message in case there's a spot color which is not defined. So it wouldn't convert the file in this case, but gives us a warning and an error in this case. Or if we want to convert it, we can use as well the alternate color space from within the PDF, because obviously the die line needs to be not exact in the way how it is converted. So we can use the less exact way of doing it with the standard way, using the alternate color space from the PDF. And the powerful functionality of Zebra is what we call the calculation methods, because the way how a spot color is converted depends a lot on how we want to print it. If we are having a very high quality proofing system, we want the precise match, and we don't care if there is a lot of process colors used that a spot color is converted to. But for production printing, where we have register issues, let's say, we want to use the least amount of channels possible. So that's maybe the option you want to use here in this case. We can let Zebra give us a warning, display a warning, and continue if a certain delta E limit is reached. 2.5 is a typical one here, and we can set this up this way. Other options that we have here for PDF processing is typically we want to embed the output, the target profile in the output intent. If it is a PDF-X document, the target output for a multicolor would be PDF-X5N. Zebra supports that and would create a PDF-X5N file. Unfortunately, there are some applications like Acrobat that do not support that. So if we want to use Acrobat now for looking at the file, we better don't embed the profile. We could either disable that checkbox here, and then it would use no output intent. So we will do that here because we want to use Acrobat later on. So that's what we want to do here. We can apply flattening. That's in some cases it is necessary if we want to convert spot colors. In our case here, it isn't. So I'll leave that off. So just say we need to click save here, and we are good to go. So our configuration is done. Our spot color definitions are defined. And what I can do now is simply right-click, open the folder, because the auto setup has set up all the folders already that we want to use. And now I simply need to get to my 2 sample files, my cat food file and the dog file here, and I will drop them into the input folder, and then Zebra will recognize those files and will start to convert the documents to our target color space and do the conversion of spot colors as well. So that takes a short while, and during the processing here, you see the first file has been converted already. To your understanding, the files that need to be converted, they need to be put into the input folder. Into the done folder, there will be the original files that we maintain, and the output folder contains the converted files. So, and we will typically add the conversion configuration and an ID here. You can change that obviously, but we just leave it alone here. And now let's have a look on our conversion. So first of all, we start with our doc image. So our doc image here, let's have a look here into our output preview. As we defined that there is no output intent, the Acrobat here uses my default setting, which is piezo coded version 3. But what we can see here is that we are now using CMYK, orange, green, violet, and obviously we are using a lot of the orange, green, violet as well in our conversion. And what's nice is with some of those colors that we had in the original, like for example, this gray text here that was gray in the original, it will be gray as well after conversion. Or this area which was 100% black before, it is maintained 100% black. That's the beauty of the DeviceLink profiles that we can use here. And obviously the other colors will improve on the rendering of the green and the here of some parts of the dog's face, so to speak. And some spot colors, like for example this pure yellow, will be retained as pure yellow at the end. So again, what you can't do that with a normal printer profile. DeviceLink profiles have this power to, with the help of exceptions, to keep colors pure if necessary and if possible. So that's the simple example. The more complex one is our cat food. Here we can see again now output intent, as we have defined that this document should be have no output intent. But we can see here again there is no Pantone color anymore. Our die cut has been converted as well, and all the colors are here converted to 7 colors, and we have a perfect conversion to 7 colors. We can have a look even here how, for example, our Pantone Reflex Blue was converted. It is using 100% of cyan, using some black and a lot of violet. And for our red color, it's using magenta and orange only. So just 2 colors basically. So that's the beauty of this method here that we're using. Spot colors use the least amount of channels possible. So depending on the colors and the possibilities of your printing process, we would select how many inks are necessary to get there. And by the way, if you select under process jobs your job and double click here, the job properties dialog will pop up, which gives you some information about what the document contains, like which kind of spot colors it has, which kind of PDFX information is available, the processing information. And what I would like to point to here is the spot color processing information. And it tells us, for example, that the Pantone red has been rendered to a delta E2000 of 1.4, so within our tolerance of 2.5, so that's fine. And the Pantone Reflex Blue has an even lower tolerance, 0.1 delta E2000. So we have a very faithful reproduction of our 2 spot colors in our 7 color space, which wouldn't be possible in a 7x only color space. Then both colors would be out of Gamut and the color rendering would be not that nice. So what we can see here is our conversion has been done. We have done it live, so to say. We can see how fast it is to set up your conversion with the complete PDF workflow here and in a very high quality.